Bill Snodgrass, and in this episode of The World Around Us, we're doing another heat exchange video. It has math. We'll talk about the math first. In this video, we're going to do the setup, the discussion, and then we're going to talk about how to collect all the data, and then we'll collect the data. The results is more about the discussion and plugging some numbers into an equation. You'll have to do your own results section, your own results, but the worksheet, which is attached, will have detailed instructions of how to complete the results and give you some hints about the discussion, the conclusion, and that sort of thing. So here's the setup. I've got my coffee, and it's hot. It's too hot to drink, so I put some cold creamer in it, and the temperature goes down. That's the practical application for this. Of course, we're not going to use coffee, we're not going to use creamer, we're going to use something where we can control some variables, because let's take a look at the math. Look at the math. MC delta T, so we got the mass of the coffee and the mass of the creamer and the specific heat of the coffee and the specific heat of the creamer and the temperature change. The coffee starts at some temperature and it goes down, and the creamer comes out of the refrigerator and the temperature goes up. And what we're trying to do is get it to a final temperature. It's very complicated, but we're going to use water for both things. And if water is both things, water is the same specific heat. So the C's all go away. See that? C's are all gone. And it leaves us with an equation that says the mass of the hot water times the temperature, the mass of the cold water times the temperature, mix them together and divide by the sum of the masses. Pretty simple. Actually, it's pretty simple. So what you're going to do is we're going to have hot water, we're going to have cold water, we're going to know the mass of the water in each of the cups, and they're marked, as you can see. And we're going to put them in together. In order to do that, we need to know the mass of the cup and the mass of the cup of the water, the mass of the cup, the mass of the cup of the water. Subtract that. Now we have the mass of the cold water and then the mass of the hot water. When we pour them together, we'll have all the masses. There'll be a few drops stuck to the bottom of the cup. We're going to ignore those few drops. Procedure-wise, we're going to weigh the cups, record that number. We're going to put water in it, record the mass of the cup and the water. Then for the hot water, this is tricky. We're going to use a syringe and a safety glove to extract hot water from the beaker of supply water over there, the boiling water. Then we're going to put that into the cup. Then we have to weigh it. So we have to weigh the cup empty, extract hot water, put it in, weigh it again, record those things. Then we have to record the initial temperature of the hot water. Now we have the initial temperature. We've already done that for the cold water. We mix them together. That's the setup for this. All right, so if you're doing the virtual lab, watch a little bit more and see how the mechanics go. I'll put the numbers up. I'll put the numbers up at the end of the results section. So let's get started. All right. Let's start by getting our data going. We have hot, cold, and then we're going to have the mass of the cup, the mass of the cup plus water, the initial temperature of the water. We're going to subtract those two to get the mass of the water. All right, so we're going to have our data. Make a nice little data chart here. I'm going to start with the cold water cup. Put it on the scale. 2.20. 2.20. The mass of the cold water cup, 2.20. Mass of the hot water cup, also 2.20. I was not expecting that. All right, we're gonna put some water in here using the tap. I'm just gonna put some water in. Didn't measure. Gonna take the mass over here. 85.78. That's the mass of the cup and the water. 85.78. If I subtract those two numbers, the mass of the water becomes 83.58. That's the mass. That's the mass of the cold water. We're going to take the temperature of the cold water. I'm not going to tell you the temperature of the cold water until later on. So if you're doing this in class, you'll have a different mass. You'll have your own initial temperature if you're doing this in class. I'll tell you in the end of the results, in the end of the procedures, we'll go into the results that we have collected. So I have an initial temperature. We'll get to that later on. All right. I'm going to set this carefully to the side. I don't want to disturb my system. All right. I'm going to do the water thing. All right. I have the mass. I have the mass of the cup, the hot water cup. I'm going to using the glove to protect my hand from the energy that it's not, I don't want to accidentally burn my hand. This hand is going to pull the stopper. I don't want to touch the hot thermometer. I don't care what the temperature is in here. I care what the temperature is once it gets in there. I'm going to put the syringe in, make sure there's no air inside. I'm going to draw. I'm going to very quickly. I'm going to keep the syringe pointing down. I'm going to spill some water between here and there. Again, I don't care what the temperature is or the amount. I just want to get some. I'm going to measure those temperatures and the amounts later. So I'll draw some in. I'm going to put it over into the cup, very careful not to spill anything. And I'm going to depress the plunger and put it into the cup. I didn't get a whole lot. I got like 25 milliliters. All right, so now I have hot water in the cup. I'm going to take the mass again. 24.66. All right, so the mass of the hot water is 24.66. Subtracting gives me a mass of the water of 22.46. That's the mass of the water. I'm going to take the initial temperature of the water. I'm not going to tell you what the initial temperature is in the process, in this procedures part. I will tell you the initial temperature in the results, which will follow. Taking the initial temperature of the water, it's not going to be 100 because I put it in the cup. It's already exchanged some heat with the air. And very quickly, after I take this initial temperature, I'm going to mix the two together. It has stopped rising, so I will record that temperature. I'll tell you what it is in the results section. Putting this into the cup, putting this into the cup. Recording that temperature. Allowing the water to come to a temperature. I'm going to take the temperature of the final temperature, which will be T sub F. All right, once I record this, we're ready for you to predict the final temperature using the formula that we came up with. And the final temperature is recorded. All right, that is the procedures. Over here, again, reiterating. Make sure that your hot water cup is very close to so you don't have to move it very far. You want it to go right in there. And that brings us to the end of the procedures. So we have our background and procedures. Let's look at the results. We recorded some of the results as we went along. The masses recorded. Let's look at the temperatures. The initial temperature of the water, the cold water, the initial temperature of the cold water was 21 degrees. The initial temperature of the hot water was 72 degrees. So using the equation that we have, the final temperature, we're going to do a predicted final temperature. The predicted final temperature is the mass, we're going to do it M sub H, T sub H, that's the initial temperature of the hot water, plus the mass of the cold, temperature of the cold, divided by the mass of the hot plus the mass of the cold. When you get a calculator, multiply those numbers, and that's going to give us the predicted final temperature. I'm going to get a calculator, and the battery's dead. Racing the battery on the camera every time. I don't know what I do. 72 times 22.46. 1,617.12 plus 21 times 83.58 equals 1,755.18 divided by 22.46 plus 83.58 equals 106.04. My predicted final temperature, clear, 1617.12 plus 1755.18 equals, divided by 106.04. The predicted final temperature, 31.80. Drum roll. What was the measured final temperature? What was the measured final temperature? The predicted final temperature was 31.08. Drum roll. The measured final temperature was 32 degrees. So the predicted, based on the initial and of the two, and the mixture and the masses, the predicted temperature was 31.80. The actual measured temperature on our thermometer that is not, broken down into tenths or anything, it was 32. That's pretty close mathematically. Let's suppose that there was 0.2 of a degree of energy where did it go? Into the cups. Into this cup, in the transfer process. This is the air. All right. We mixed water. Now, people always ask me, how does this apply to my real life? Every single day, I take cold creamer from the refrigerator and put it in the hot coffee from the coffee maker, and I mix it, and then it makes the temperature go down. I do that every day. A guy in class puts ice in his coffee. So we do this every day. We do this every day. This is we just don't do the math. We just put the creamer in until it doesn't burn our mouth. Hey, that's a good video. The battery didn't die. Thanks for watching. I don't even think I have any bloopers for this one. Sorry about that. See you in the next one. Click the like button, subscribe to the channel, sign up for notifications, leave me a comment, question, or suggestion. That's all. I don't know what that is. That could be an outtake right there in itself. Maybe I'll do a pin flip. Staring right into a light is hard to see.